Hi everyone. So today we will continue to talk about discrete time Markov chain. So hopefully we can handle all three examples that I prepared today. Okay, here's the first example problem. Okay. Okay, so let me read the problem description first. Cold Spot manufactures refrigerators, and the company has issued a warranty on all refrigerators that requires free replacement of any refrigerator that fails before it is 3 years old. Okay. And 3% of all new refrigerators fail during their first year of operation. So in that case, we assume that it is replaced by the new one. Okay. Also, 5% of all 1-year-old refrigerators fail during their second year of operation, and 7% of all 2-year-old refrigerators fail during their third year of operation. Okay. And the replacement refrigerators are not covered by the warranty. Of course, this is very realistic assumption, right? Okay, the question is, what fraction of the refrigerators will Cold Spot have to replace? Okay, so to answer the question, the first step is for us to define the state of system, right? And then, based on that state of system that we defined, we're going to construct one-step transition probability matrix. Okay? So let me give you a couple of minutes. Why don't you think about how you could define the state of system? Okay? Okay, what if we define 4 states? For example, okay. Let's say state number 1 represents the new refrigerator as well as the replaced. And state number 2 would be 1-year-old refrigerator. State number 3 is the 2 years old. And state number 4 would be older than 2 years old. Okay, so it would be older than 2 years old. So if we define these 4 states of system, then we can draw the transition diagram. So according to the problem description, it says 3% of all new refrigerators fail during the first year of operation. So all of those failed refrigerators will be replaced by new one, right? So we're going to have this transition 1-to-1 with 3%, right? That's going to be 0.03. Unless otherwise, year later, it becomes 1-year-old refrigerator, right? So in this case, each transition takes 1 year, okay? So this is going to be 1 minus 0.03, which is 0.97. Is that right? Okay, starting from 1-year-old refrigerator, it has 5% of chances it will be failed during their second year of operation. So we have 0.05 here. Unless otherwise, year later, it becomes 2-year-old refrigerator, right? So that's going to be 1 minus 0.05, which is 0.95. Does that make sense, right? And here, 2-year-old refrigerator will fail. So replaced by new one, 7%, right? Unless otherwise, it becomes 3-year-old, right? So we have 0.93. Is that right? How about starting from state number 4? What transitions do we have? It's going to be 1. Why? Because if the refrigerators are older than 2 years, then it is not covered by warranty. Is that right? So we have here absorbing state. State number 4 is got to be absorbing state. Does that make sense? Okay, so based on that, we can build up one-step transition probability matrix, P. So starting from 1 to 1 is 0.03, 1 to 2 is 0.97, 1 to 3 and 4 become 0, right? 2 to 1 is 0.05, 2 to 3 is 0.95. Otherwise become 0. 3 to 1 is 0.07. 2 to 3 is 0.93. Now we have 0 down here. And 4 to 4 is 1. Otherwise becomes 0. Okay? So it's very clear to see that state number 4 is absorbing state, right? Which means all other states, 1, 2, 3's transient state, right? So obviously, this one-step transition probability matrix P is a absorbing Markov chain, right? So we are going to use absorption analysis as the very first step. We're going to have matrix partition like this, right? So we have here, down here, we have identity matrix, and 0. Where do you have Q? Ah, I did wrong. Sorry. We cannot do this, right? We can have partition like this. Sorry. So we have here identity matrix, 0 matrix, same, and we have Q matrix up here, right? And then this is going to be R. Is that right? Okay. So let's go back to the problem description. Okay, so the question we need to answer is, what fraction of the refrigerators will cold spot have to replace? So what information do you need to answer for this question? We need A matrix, right? So A is E times R. Is that right? We already know R matrix here, but we do not know E matrix yet. So how'd you get E matrix? I minus Q, and then get the inverse, right? So we already have Q matrix up here, which is 3 by 3. So we should get this value, right? And then I'm going to use identity matrix, which must be 3 by 3, right? 1, 1, 1, 0, 0, 0, minus this Q matrix. And then after that, we're going to take inverse, right? That's what you need to do. So what is that? That's going to be 0.97, and then 0.03 and 0. Should be minus, right? Sign there. And then negative. Oh, no. This is wrong. Oh, okay. Let me put this number so that I don't make any error. So down here we have 0.03, 0.05, 0.07, 0.97, 0, 0, 0, 0, 0.95. Okay. So 1 minus 0.03 is 0.97. That's going to be negative 0.97, right? And then negative 0.05. 1, negative 0.95. Negative 0.07. 0, 1. And then we have negative, inverse matrix. get it. So does anybody have a good calculator? You already got it?
Yeah. So the first one is 1.16.
1.16.
1669.
And then?
Okay, and 1.13.
3.13. Okay.
107.
1.07.
0.13.
0.13.
1.13.
1.13.
And 1.07.
7.
0.08.
0.08.
Yes.
Okay, thank you.
0.07. 0.08.
08. Okay, and then
1.07.
it should be the same. Okay. So this is our E matrix. Thank you. Okay. So now we should be able to get A matrix, right? So it should be E times R. This is E matrix, right? And up here we have R matrix, which is 3 by 1 matrix. So you need to multiply that. Then we should be able to get A matrix. Should be 3 by 1 matrix then. So could you give me the number for that?
.96.
0.96?
Yeah. And 0.96. All of them 0.96.
0.96. Okay. Could you give me more accurate number here? Instead of 1.16, maybe, no. Because this number is got to be 1, actually, all of them. Okay? If you have more accurate value here, probably there's some rounding error, maybe. So anyway, we're going to end up with or 1, the value of 1. So actually, what I want to tell you at the moment here is that we cannot answer for the question with the current setting. Okay? Do you know why? Up here, when you define the state of system, state number 1 represents both states. It's a new refrigerator as well as the replacement refrigerator. Okay? So, the thing is, replacement refrigerators are not covered by warranty, right? But the new refrigerator will be covered by warranty. Okay? So, what you need is break it down, the state number 1, into 2 different states. Okay? We cannot simply combine these 2 in 1 state. Okay? So next, what I'm going to do is I'm going to add another state representing refrigerators replaced. And then the first state will be just new refrigerator, not including this part. Okay, that's what I'm going to do. So here, our state number 1 is just new refrigerator, okay? And then state number 2 is 1 year old as before. State number 3 is 2 years old. State number 4 will be older than 2 years old. And state number 5 represents replaced machine. Okay, so now we are going to use 5 different states, okay, to build up our Markov chain model. So we have state number 1, and then 2, and then 3, 4, and then let's put state number 5, the center. Okay. So starting from new refrigerator, %3 of chances it will be replaced. Right? So we have 0.03. Unless otherwise, it becomes 1 year old machine, right? So we have 0.97. Starting from 1 year old, %5 of them will be failed, so that it will be replaced. Okay, so this is replaced. This is new machine, right? Unless otherwise, it will be survived. So 95% chances. Okay. Similarly, 7% will be replaced, and then 93% will be survived. Okay. As before, this is going to be absorbing state, right? Once it becomes older than 2 years machine, then it just stay there, right? And of course, we have one more absorbing state here. Once it's replaced, it just remains in the replaced, right? That's going to be 1 as well. Does that make sense to everyone? Okay. So in this diagram, it's easily seen that we have 2 absorbing states. Those are state number 4 and state number 5, right? Okay, now based on this, let's make a one-step transition probability matrix. So we have 0.97, 0, 0, and 0.03, right? And 0, 0, 0.95, 0, 0.05. Is that right? Okay. And then we have 0, 0, 0, 0.93, 0.07. And we have 1, 1 down here, and all others are 0. So this is our one-step transition probability matrix. Okay. As before, next step is to partitioning of the matrix, like this. So we have identity matrix, zero matrix, and up here we have Q matrix and R matrix, right? So again, we need to have E matrix. First, right after that, we are able to get A matrix. So could you give me the numbers? I need to move this down a little bit. Yeah. So do you have this value? 1. 0.97, 92, 0, 1, 95, 0, and 1. Okay, then do you have A matrix as well? A matrix has to be 3 by 2, right? Is that 0.85? A6? 0.41? Okay. 0.88? 0.12? 0.93? 0.07? Well, I think something wrong in the first row, because summation of the first row, each row has to be equal to 1. So, give me any corrections for that?
14.
Mhm.
0.8.
Oh, okay. So
0.14.
this is really 14. Okay. Okay, thank you. Yeah. Then this just makes sense because summation of each row is now becomes 1. Okay. Okay, now let's go back to the original problem description. So we need to answer for this question. What fraction of the refrigerators will cold spot have to replace? So how do you answer for this question? Of course, these are the state 1, 2, 3, and then 4, 5, right? So what is the answer? Right, 14%. Is that correct? Right? Because state number 5 represents the replaced. Right? State number 1 is the new refrigerator. Starting from new refrigerator, about 14% of them will be replaced. Make sense? Okay? Okay, now let's work on another example. Let me see. Yeah, let's work on this example, second example, video cassette recorder example. Let me distribute this. So please read the problem description and then think about how to formulate Markov chain model for that. So this example would be very similar to what you've done just ago. Okay, so let's read the problem description together. A video cassette recorder manufacturer is so certain of its quality control that it is offering a complete replacement warranty if a recorder fails within 2 years. Based upon compiled data, the company has noted that only 3% of its recorders fail during the first year, whereas 17% of the recorders that survive the first year will fail during the second year. And the warranty does not cover replacement recorders. Okay, now Okay. We are required to formulate the evaluation of the status of a recorder as a Markov chain whose states include two absorption states that involve needing to honor the warranty or having the recorder survive the warranty period. Then construct the one-step transition probability matrix. And then we're going to find the probability that the manufacturer will have to honor the warranty. Okay, so this is very similar to what we've done earlier, right? Okay. Okay, so first, let's define the state of system. Okay. So in our case, the first state represents the recorder replaced. And then state number 2 represents recorder in the first year. State number 3 will be the recorder and the second year. State number 4 would be recorder and the third year, or older. Okay. So using this four state, let's construct the transition diagram and the one-step transition probability matrix. So we have 4 states, right? 1, 2, 3, and 4. So once it's replaced, it will remain replaced, right? As a replaced, being replaced. So it's going to be 100%. How about starting from state number 2? What transitions do we have? It will be replaced with 3% of chance, right? Unless otherwise it becomes survive, right? So 97% of chance. Likewise, it will be replaced with 17%. Is it right? Hold on a second. Right, that's 17%. Unless otherwise, it will be survived with 83%. Right? And then we have another absorbing state, right? State number 4. Does that make sense? Right? Okay, so based on that, let's have a transition probability matrix. So we have 4x4 matrix, right? So we have 1, 0, 0, 0. And then 0.03, 0, 0.97, and 0, right? 0.17, 0, 0, and A3, right? And we have 0, 0, 0, and 1. Is that right? Okay, yes. So next is the matrix partition. So how do you do the matrix partition? So currently we have here 1, 2, 3, 4, 1, 2, 3, 4. We need to resort the state of the system, right? So what I'm going to do is either move state number 4 before state number 1, or move state number 1 after state number 5, state number 4, okay? So either is fine. So let's resort the state of system. So instead of 1, 2, 3, 4, we can have 4, 1, 2, 3. 4, 1, 2, 3. Like that. Okay? So 4 to 4 is 1, 1 to 1 is 1, right? 2 to 1 is 0.03. 2 to 3 is 0.97, right? What about 3 to 1? 0.17. 3 to 4 is 0.83. 0.83. What else? Is that all? Right? That's it? All others are 0. Now, we should be able to partition the matrix. Is that right? Easy? Very easy. Now we have identity matrix, 0 matrix. Where do you have Q matrix then? Below 0 here? We have Q matrix, right? And then this becomes R matrix. Is that right? So now you should be able to get E matrix. And A matrix. Is that right? So could you give me the number for that? Did you get the number? Both should be 2 by 2 matrix, right?
4.3.
Did you get it? This one, E matrix. 1? 0.97? 0? 1? Okay. Then did you get this as well? Okay, thank you. So down here. Okay, to answer for the second question, question B, find the probability that the manufacturer will have to honor the warranty. We need the A matrix, right? To answer to the question.
Point 81.
0.81?
Yeah, 81, yeah. Point
0.19?
19. Point
83, then 0.17. Okay. So, how do you answer for the question?
19.
0.19 up here, right? So we are starting in state number 2, right? Which is recorder in the first year. It will be replaced. So it's got to be 19%. Is that right? Okay. How do you feel? Is that easy? Right? Sorta? Okay. Let me give you another example. And this example is also very similar to what we've done. Now let me give you a couple of minutes. Try to read through the problem description and then build up Markov chain model. Okay? Okay. So let's read the problem description first. The Herald Tribune has obtained the following information about its subscribers. During the first year as subscribers, 30% of all subscribers cancel their subscription. Of those who have subscribed for 1 year, 20% cancel during the second year. Of those who have been subscribing for more than 2 years, 10% will cancel during any given year. On the average, starting from new subscriber, how long does a subscriber subscribe to this newspaper? So what information do we need to answer for the question? We need E matrix, okay, at the moment. So as usual, the very first step is to define the state of system. And then using the state of system that you defined, build up one-step transition probability matrix. Okay? And obviously, this matrix will contain observing state, right? Because in that case, we assume that once people cancel their subscription, we assume that they will never resubscribe. Okay? Let's make this assumption so that one of the state you defined becomes absorbing state. Okay? So let's do that. Okay. So here, let's say state 1 is the new subscriber. Okay. State 2 is 1 year subscriber. State 3 is more than 1 year subscriber. Okay, more than 1 year. And then last state number 4 would be, let's say, cancelled. So we're going to use these 4 different states. And we have 1, 2, 3, 4. Okay. So 1 to 2 becomes what? 0.7. 1 to 4 becomes 0.3, right? Likewise, 2 to 4 becomes 0.2, right? Which means 2 to 3 becomes, or minus 0.2, which is 0.8. And 3 to 4 becomes 0.1, right? And then 3 to 3 becomes 0.9. Is that right? And then 4 to 4 becomes 100%. Simple, right? Now we should be able to get one-step transition probability matrix. It's going to be 0, 0.7, 0, 0.3, 0, 0, 0.8, 0.2, 0, 0, the 0.9, and 0.1, 0, 0, 0, 1. Okay. Now we can easily divide into 4 different sections like that. So we have identity matrix down here, 0 matrix, and we have Q and R. Is that right? Now, you should be able to get E matrix. So, could you give me that number? I'm sorry, did you get it? It's 3 by 3 matrix.
3 by 3. My calculator is so old, so it just twist up the numbers all the time. So I'm not sure about it because it's showing 7.2.
Which one is 7.2?
1, 3.
1?
Yeah, it's not making sense. 1 matrix 1 and column 3 showing 7.2. So I'm not sure about the result. The matrix, I mean, this is the calculator, I'm not sure.
Okay. Does anybody, you have number? 1? 0.7? 5.6? 0? 1? 8? 0, 0, 10? Okay. Now, how'd you answer? It's asking you, on the average, starting from new subscriber, how long does a subscriber subscribe to this newspaper? So using this E matrix, how'd you answer for that? So we are starting in state number 1, right? So we need to look for the first row, which is a new subscriber, right? The expected number of years that the people remains subscriber. How many years? How'd you get it? 1 plus 0.7 plus 5.6. How much is that? 7.3 years. That's my answer. Is that right? Make sense? Okay, so this is all for today. So if you have time at home, try to practice. Okay? If I were you, I'm going to try to define the state of system my own way, and then build up Markov chain model, and then compare with my solution. Okay? Don't just copy everything from the very beginning. Okay? Try to think first, do your own way, and then compare with my solution. Okay, thank you very much. We'll see you next time. Have a good one. Bye-bye.